For centuries, humanity has stared into the cosmic abyss, searching for a sign that we are not alone. We expected a radio signal, a stray transmission, or perhaps a rhythmic pulse of light. What we did not expect was to find a shadow. In the constellation Cygnus, nearly 1,500 light-years away, a star known as KIC 846-2852, often called Tabby star, began to behave in a way that defied every known law of astrophysics. While stars typically dim slightly when a planet passes in front of them, this star was experiencing massive, erratic plunges in brightness. It wasn't a steady orbit. It was a chaotic flickering, as if something gargantuan and irregular was blocking its light. When the Kepler Space Telescope first captured this data, scientists assumed it was a mechanical glitch. In the vacuum of space, nature follows a predictable rhythm. A planet the size of Jupiter would only block about 1% of a star's light, and it would do so with mathematical precision. But Tabby's star was losing up to 22% of its luminosity at irregular intervals. This was not a planet. This was not a swarm of comets. The scale of the obstruction was so immense that it challenged our fundamental understanding of celestial mechanics. It was a discovery that sent a chill through the scientific community, suggesting that we were looking at something that should not exist. The data presented a terrifying reality. Whatever was circling that distant sun was larger than any planet in our solar system, yet possessed no discernible natural shape. Astronomers worldwide pivoted their most powerful instruments toward that flickering point in the sky, desperate to find a natural explanation. Dust clouds, shattered moons, or planetary collisions. Yet, every natural theory fell short. The more we looked, the more the flickering felt deliberate. It felt like a signature. For the first time in history, we had confronted a possibility that was once reserved for fringes of science fiction. If nature did not build this, then something else did. As the flickering continued, a realization began to settle over the observatories of Earth. We were not witnessing a simple astronomical event. We were looking at a construction project on a stellar scale. The impossible dips in light were not just shadows. They were first evidence of an engineering feat, so advanced it made human civilization look like ants building in the dirt. Something was out there, wrapping itself around the sun, harvesting its fire. And as the scientific world scrambled for answers, we realized that the laws of physics weren't broken. They were simply being rewritten by an intelligence far greater than our own. We were staring at the dawn of a mystery that would change our place in the universe forever, leading us to wonder if we had finally found the masters of the cosmos, or if they had found us first. The scientific community's first instinct was to seek refuge in the familiar. Faced with the impossible data from Tabby's star, astronomers scrambled to find a natural explanation that would preserve our understanding of the universe. The most popular theory was the comet hypothesis, suggesting that a massive swarm of giant, fragmented comets had been pulled into a tight orbit around the star. On paper, it seemed plausible. A cluster of icy debris could, in theory, block large portions of light. However, as the numbers were crunched, the math began to fall apart. To block 22% of the star's light, the number of comets required would be in the thousands, each one hundreds of kilometers wide, all perfectly synchronized in a way that nature rarely, if ever, permits. The probability was near zero, and yet it was still the most rational, natural explanation we had. Then came the dust cloud theory, proposing that a colossal belt of interstellar dust was passing between Earth and the distant sun. But this, too, hit a scientific dead end known as the infrared mystery. According to the laws of thermodynamics, any natural object, be it dust, a planet, or a comet, that absorbs such a massive amount of starlight must radiate that energy back out as heat. This creates a distinct infrared excess that our telescopes can easily detect. But when we pointed our most sensitive heat-seeking instruments at KIC 846-2852, we found nothing. The star was dimming, but it wasn't getting warmer. The thermal footprint that nature always leaves behind was missing. It was as if the energy wasn't just being blocked. It was being consumed. This lack of infrared radiation was the final blow to the natural world. If a planet or a moon had shattered in a violent collision, the glowing debris would have lit up the infrared spectrum like a beacon. Instead, there was only a cold, calculated silence. The patterns of the dimming were too irregular for a planet, too massive for a comet swarm, and too clean for a dust cloud. We were forced to move beyond the boundaries of natural physics. If the obstruction was not a chaotic mess of rocks and ice, then it had to be a structured, deliberate arrangement of matter. We were no longer looking at an accident of the cosmos. We were looking at an intentional redirection of energy on a scale that shattered our definitions of life and technology. The shadows were not a celestial anomaly. They were the blueprint of an alien titan. While the telescopes of the 21st century struggled to categorize the darkness around KIC 846, 2852, the theoretical blueprint for such a nightmare had already been drawn decades earlier. In 1960, a visionary physicist named Freeman Dyson published a paper that would redefine our expectations of alien life. He proposed a terrifyingly logical progression for any advanced society. As a civilization expands, its hunger for energy becomes insatiable. Eventually, the resources of a single planet, the wind, the tides, and the minerals, would become mere drops in an ocean of need. To survive and continue their technological ascent, such a species would be forced to look toward the only true powerhouse in their vicinity, their parent star. Dyson's prophecy suggested that a sufficiently advanced civilization would not just live near their sun, but would attempt to own it. He theorized that they would dismantle the dead planets and asteroids of their solar system, using the raw materials to construct a massive, hollow shell or a vast, dense swarm of collectors that would encase the entire star. This structure, now famously known as a Dyson Sphere, would trap every single watt of energy and every stray photon of light, leaving the star almost invisible to the outside world, while providing the creators with nearly infinite power. What was once a wild mathematical curiosity in the mid-20th century suddenly became a chillingly accurate description of the flickering star in Cygnus. The shadows we were witnessing were no longer just a scientific anomaly. They were the physical manifestation of a prophecy that had been waiting 60 years for a witness. If Dyson was correct, we weren't just looking at an alien structure. We were looking at the inevitable endpoint of all intelligent life. A Dyson sphere represents the total mastery over nature, where a star is no longer a god to be worshipped, but fuel source to be consumed. As the realization dawned on the world's astronomers, the question shifted from what it was to how it was built. We had found the shell, but the scale of the engineering required to build was so immense that it defied human imagination, leading us into the heart of construction itself. The term Dyson Sphere often conjured the image of a solid, impenetrable shell, a metallic cage completely enclosing the sun. However, the laws of physics and structural integrity suggest something far more complex and terrifying. A solid shell of that magnitude would be unstable, prone to drifting and eventually shattering under the immense gravitational pull of the star it sought to contain. Instead, what astronomers believe they are witnessing is a Dyson swarm. This is not a single wall of steel, but a chaotic yet coordinated web of trillions of individual solar collectors, each the size of a modern city, orbiting the star in a dense, multi-layer formation. From a distance, this swarm would look like a shimmering cloud of golden dust, but up close, it is a megastructure that dwarfs our entire planetary history. To understand the sheer scale of this architecture is to realize the insignificance of human achievement. To build even a partial swarm around a star like our sun will require the total dismantling of every planet, moon, and asteroid in a solar system. Every mountain on Earth, every drop of water in our oceans, and every ounce of iron in our core will be nothing more than a handful of raw material for such a project. We are talking about a structure with a surface area millions of times larger than that of the Earth. If you were to flatten out the surface of a completed Dyson swarm, you could fit every human being who has ever lived onto a single collector, and still have enough room left over for a billion more civilizations just like ours. The visual reality of this structure is a testament to an intelligence that has moved beyond the constraints of a home planet. While humanity struggles to build skyscrapers that reach the clouds, these architects have reshaped the very fabric of their solar system. Earth, in the shadow of such construction, is not even a footnote. It is a speck of dust floating in the wake of a titan. The flickering light of KIC 846. 2852 is the rhythmic heartbeat of this machine, a sign that the creators have successfully enslaved their sun. But as we look at this impossible grid of collectors, a darker question begins to emerge. Why would any civilization need this much power? And what happens to the star when it is being drained of its lifeblood every single second? The harvest of a star is not a passive event. It is a slow, methodical extraction of life. In nature, a star is the beating heart of its solar system, radiating warmth and light in every direction for billions of years. But under the shadow of a Dyson swarm, that light never reaches the planets. Instead, trillions of massive solar collectors act like a sponge, soaking up every photon and every wave of radiation before it can escape into the void. This is the great dilemma of advanced engineering. To fuel the impossible dreams of a Type II civilization, a star must be treated not as a celestial wonder, but as a battery. Every megawatt gathered by the swarm is energy stolen from a natural life cycle of the sun. As the swarm grows denser, the physical toll on the star becomes visible across the light years. The erratic dimming we observe from Earth is a symptom of a dying sun. By trapping the star's radiation, the structure begins to alter the star's very environment. The natural pressure that keeps a star stable is governed by the flow of energy from its core to its surface. When a gargantuan machine surrounds that surface, it creates a feedback loop that can shift the star's temperature and magnetic behavior. The star begins to flicker, not just because it is being blocked, but because it is being stressed. It is a parasitic relationship on a cosmic scale, a celestial murder committed over thousands of years to keep a distant civilization alive. This process reveals the dark cost of infinite power. For every new city built and every new world terraformed by the creators, their parent star grows a little colder and a little dimmer. The majestic fire that once gave life to an entire solar system is now being channeled into wires, circuits, and processors. To the outside observer, the star is vanishing, fading into a ghost of its former self. We are witnessing the ultimate sacrifice of the natural world for the sake of technological survival. The star is being drained of its fire so that a master race can conquer the dark, leaving us to wonder if this is the inevitable fate of every sun in the universe, to be consumed by the very life it helped create. To understand the hands that built such a monster, we must look at the scale of civilization itself. In 1964, Soviet astronomer Nikolai Kardashev developed a method of measuring a civilization's level of technological advancement based on the amount of energy they are able to use. On this scale, humanity is still a Type 0 civilization. We are a species that still depends on dead plants and ancient sunlight trapped in fossil fuels. We are confined to a single planet, vulnerable to every stray asteroid and every shift in our climate. But the architects of the Dyson swarm have transcended these primitive limitations. They have reached the status of a Type II civilization, a species that has outgrown its cradle and claimed its entire solar system as its own. A Type II civilization does not just inhabit a solar system, they command it. Their energy needs are 4 trillion times greater than what all humanity consumes today. To them, a star is not a distant object of wonder, but a domestic resource, no different from how we view a battery or a light bulb. Their computers might be the size of planets, capable of simulating entire universes in a single second. Their medicine might have conquered death itself, and their engines could likely fold the fabric of space to travel between the stars. When we look at the flickering light of KIC 846, 2852, we are looking at a shadow cast by a godlike intelligence that has been evolving for millions of years longer than our own. The gap between us and the creators of the Dyson swarm is not just a gap of years. It is a gap of evolution. If a Roman soldier were to see a modern smartphone, he might call it magic. But even that comparison fails here. To us, the engineering of a Dyson swarm is so far beyond our reach that it appears indistinguishable from the divine. They have moved from being subjects of the universe to being its managers. They have solved every problem that currently threatens human existence: hunger, energy, and planetary decay. Yet, as we stare in awe at their power, a chilling silence remains. If they are so powerful and their machines are so vast, why have we heard nothing but the cold, rhythmic dimming of a dying sun? When we witness the dimming of a distant sun, we are witnessing more than just a feat of engineering. We are witnessing a choice. In the vast, cold expanse of the universe, the law of survival is absolute. To a Type 2 civilization, the decision to encase a star is likely not a matter of greed, but a matter of necessity. As a species grows, its thirst for data, space, and energy becomes an uncontrollable force. To stop expanding is to stagnate, and to stagnate is to die. From their perspective, the star is not a sacred object to be left alone. It is a resource that must be harvested to prevent the extinction of trillions of souls. But this raises a haunting ethical dilemma that challenges our very definition of right and wrong. Does a civilization have the right to claim a sun for itself? By building a Dyson swarm, these architects are effectively ending the natural history of their solar system. Any potential life that might have evolved on distant, frozen moons is instantly snuffed out as the swarm intercepts the life-giving warmth of the star. It is a form of cosmic ego, the belief that one's own survival is worth the extinction of a star's natural future. We are forced to ask, is this the ultimate evolution of intelligence, or is it a form of planetary parasitism? If we were in their position, facing the slow death of our own resources, will we hesitate to tear apart our moon and our planets to build a cage around our own sun? The dilemma of the Dyson Sphere is that it turns a solar system into a closed machine. There is no room for the chaotic beauty of nature when every atom must be accounted for in a grand energy budget. This is the dark side of progress, the transition from being part of the universe to being its absolute owner. The flickering light of KIC 846. 2852 is a signal of a species that has won the battle for survival, but perhaps at the cost of its connection to the natural cosmos. They have secured their future, but in doing so, they have turned their sun into a ghost. As we ponder the morality of their actions, we must face an even more unsettling truth. We have found the machine, and we have analyzed its ethics, but the creators themselves remain invisible. The discovery of a megastructure should have been the greatest conversation in human history. Once the anomalies of KIC 846, 2852 were confirmed, the world's most powerful radio telescopes, including the SETI Institute arrays, were pointed directly at the flickering star. We listened for the hum of a planetary internet, the pulse of a laser communication network, or the rhythmic beat of a beacon. We expected to hear a civilization that had conquered its sun to be shouting into void, proud of its achievement. But as the years passed and the data was analyzed, we found something far more unsettling than an alien signal. We found absolute, crushing silence. There were no radio waves, no stray transmissions, and no digital footprints. The masters of the Dyson swarm were effectively ghosts. This silence has led to a haunting realization among astronomers. Perhaps they aren't ignoring us. Perhaps they simply don't see us as worth talking to. To a Type 2 civilization, humanity might appear as nothing more than biological noise, no more significant than the chirping of insects in a distant forest. But there is a darker theory that keeps scientists awake at night. If a civilization is advanced enough to dismantle planets and cage a star, their methods of communication would likely be as far beyond radio waves as a smartphone is beyond a smoke signal. They might be communicating through gravitational waves or neutrinos, languages we are still too primitive to translate. Or worse, the silence could mean that the creators are no longer there. The search for the creators has brought us face to face with the great silence. If the Dyson swarm is still functioning, it is doing so with the cold efficiency of an automated machine. It is possible that the species that built it has long since uploaded their consciousness into a digital heaven within the structure's vast processors, leaving the physical world behind. Or perhaps, after harvesting the star's energy for millions of years, they simply moved on to the next sun, leaving their titanic ruins to flicker in the dark like a lighthouse with no keeper. We are staring at the greatest engineering feat in the galaxy, yet we are left wondering if we are looking at a bustling metropolis or a cosmic tomb. The flickering of Tabby's star is not just a distant curiosity. It is a mirror reflecting the potential destiny of our own species. As we sit on our pale blued, consuming the limited resources of a single planet, we are already beginning to feel the walls closing in. Our history is a relentless march toward greater energy consumption. From the first fire tamed by our ancestors to the massive nuclear reactors of today, humanity's survival has always been tied to its ability to harvest power. If we are to survive for another 10,000 years, if we are to become a multiplanetary species that outlives its own cradle, we will eventually reach a point where the Earth is no longer enough. We will be forced to look at our own sun and ask the same cold, calculated question: how do we claim its fire? The Dyson Dilemma is the ultimate test of an intelligent species. It suggests that a Dyson Sphere is not an anomaly, but a universal milestone, the great filter of cosmic evolution. To reach Type 2 status is to secure the immortality of a civilization, providing it with enough power to simulate entire realities or travel across the galaxy. But it comes at a price that we are only beginning to understand. To build our own swarm, we would have to sacrifice the familiar night sky. We would have to dismantle the silent beauty of the moon, the red deserts of Mars, and the gas giants of our outer solar system. We would be trading the natural wonder of the heavens for the artificial safety of a machine. Is this the inevitable endpoint of all intelligence? To turn the universe into a factory? As we contemplate the architecture around KIC 846-2852, we are forced to confront our own reflections. Are we looking at our future masters, or are we looking at our future selves? Perhaps the reason the universe is so silent is because every advanced civilization eventually retreats into the warmth of its own Dyson Sphere, living within a digital paradise fueled by a dying star. The Dyson Dilemma is a choice between remaining a fragile part of nature or becoming its absolute owner. The flickering light in the constellation Cygnus is a reminder that the path to the stars is paved with the wreckage of planets and the enslavement of suns. We are left to wonder if we have the courage to follow that path, or if we are destined to remain in the shadows of those who already have. Every fire, no matter how grand, eventually burns itself out in the cold mathematics of the universe. Even a star encased in a Dyson swarm has a finite lifespan. For millions of years, the creators harvested every spark and every flare, fueling an empire that likely spanned light years. But as the centuries turn into eons, the inevitable occurs. The star's internal pressure begins to fail. Its core, once a fusion engine of unimaginable power, becomes a cold, dense lump of iron and ash. The flickering light that we once observed from Earth finally stops. The shadows that once danced across the telescopes of ancient astronomers are now swallowed by a permanent, chilling darkness. The harvest is over, and the sun is dead. What remains is a monument to the ultimate hubris of intelligence. A trillion solar collectors, once the pride of a Type 2 civilization, now drift in a silent, lightless orbit. Without the warmth of their parent star, the cities within the swarm grow cold. The digital paradises, once powered by the stolen fire of the sun, flicker out into nothingness. The great Dyson swarm, which was built to ensure the eternal survival of a species, is transformed into a hollow, metallic graveyard, a cosmic tomb circling a ghost. The very machine that was designed to conquer nature has now been defeated by the slow, relentless crawl of entropy. The architects are gone, and their greatest achievement is now just a collection of drifting debris in the vast, indifferent void. The Dyson Dilemma is not just a story of alien engineering. It is a lesson in the limits of power. We look at the dimming star in Cygnus, and we see the peak of technological ambition, but we also see its inevitable conclusion. No matter how many stars we cage or how many planets we dismantle, we cannot escape the finality of the cosmos. The universe is a graveyard of civilizations that once thought they had solved the problem of survival. As the last spark of KIC 846-2852 fades into black, we are left on our fragile planet with newfound respect for the natural light of our own Sunday. Perhaps the true mastery of life is not in owning a star, but in learning to live in harmony with its light, before the shadows finally claim us all.